Hello and welcome to the 50th episode of the SMC Journal podcast, where it's all about performance engineering and IT today. I'm Scott Moore, your host. Wow, has it been 50 episodes already? Crazy, right? Yeah. So last episode, I kind of left you a little hanging because I was talking about random interval pacing with load testing, and you can go check that out in the other episode, and I'll make sure there's links. But I didn't say that there was this free download and where it was located because I went over a spreadsheet. So I'm going to go over it more in detail today about the actual spreadsheet where I use random interval pacing, but it's part of a bigger spreadsheet called the Performance Scenario Builder. And I'm going to share that with you today. But the first thing I want to share with you, which was in the show notes, but I just didn't mention it online, is where you can go to download this for yourself. It's a free download. And here it is. So you just go to the either the bit.ly link, the URL shortened link down there, or you can just scan the QR code, or you can go to the smcjournal.com and find this episode or the previous episode, or you can go to the YouTube channel and see that we have put this link in the show notes. So I didn't really leave you hanging. That's where you can actually download this spreadsheet. And that's what we're going to talk about today, is what I'm doing with this spreadsheet and how I use it to do load testing. And before we do that, let's talk about our wonderful sponsors, including Micro Focus, the makers of LoadRunner Professional, Enterprise, Cloud, and Developer. They have the largest community of practitioners in the world, and you can join that community if you just go to community.microfocus.com. If you scan the QR code that's on your screen right now, it'll take you to the Micro Focus Performance Engineering page for the entire LoadRunner family, and there's a lot to take in there. I'm also sharing links for a YouTube playlist that Micro Focus has put together all around performance engineering, so it'll be a great thing for you to look at. We are also sponsored by Keysight Technologies, the maker of Eggplant Performance. This is a load testing tool that supports web, Citrix, and low-level TCP/IP protocols to help you meet your application performance testing needs, complete with real-time monitoring and integrated test results analysis. Find out more at eggplantsoftware.com. And my friends at Total Performance Consulting are also sponsoring this episode. Love those guys. Total Performance Consulting has hundreds of years of combined experience in performance testing, development services since 2006. And they have some very highly qualified performance engineers to help you tackle even your most complicated and complex performance challenging. Whether it's performance testing, analysis, monitoring, setting up CI/CD pipelines, and many other of these kinds of services, they can help you and your company get, keep, and extend your competitive advantage. So thank you very much, sponsors, for your support of the performance testing community. So the Performance Test Scenario Builder. This is what the spreadsheet looks like at a very large level. Anything that you see that's in this like aqua bluish color are things that you would put in to the spreadsheet, and the things that are in yellow are generally calculations that are done for you. And you're also going to notice that there's some red alerting above and below the sections in yellow, and this is sort of a guardrail here, so that if you start putting in values that it knows would not be correct because you're blowing your volumes out of whack from what you said you wanted, kind of says, you know, you need to adjust these numbers, and it helps you tweak them. And then we've got this little graphic that as you create this, creates this little pie graph to show you how your users are distributed. And there is a second tab on here which shows some statistics around transactions, number of pages, and number of requests per test, and shows you how your deviations, which is what we were talking about in our last episode, how your deviations affect these numbers, what you can expect if you're running your users too hot and heavy and you're getting too much for the volume that you expected, or too little, or if you're it kind of helps you figure out if you've kind of hit the bullseye or not. How close. So how did all this come about? Myself just needing a way to organize the load test scenario as a whole. Notice I had already created my scripts in my load testing tool, and now I'm putting them together, and I'm asking a lot of leading questions to the organization to say, Okay, as I always do, who are your users? What are they doing? How often are they doing it? Let's put together the number of business processes or user stories that match the scope that we want to achieve. And we're limited on time. We can only test so much for the amount of time. As a consultant, I'm limited on time. You as an employee may have all the time in the world to work on as many projects as you want. But typically, I'm coming from that consultant mentality. I'm brought in for a period of time. I need to accomplish this, this, and this, and then get out. We'll see you later. And that's okay with me. That's my relationship with the client. But I have to go in there and just nail this thing. So I'm asking a lot of questions up front, and sometimes it's multiple conversations with multiple roles. I'm talking to the business about business value. I'm talking to the technical people about technical information that I need to put this test together. So let's go back to our spreadsheet, and I'll show you as I'm having these conversations what I'm going to put in. I'm going to want to know the number of business processes that I'm going to have to automate. Well, in this case, this is all just bogus data. We used to call these automated business processes that made up a load test scenario the heavy hitters. And usually in the LoadRunner days when I was doing that, it was about 5 or 6 business processes that were made up of 10 to 15 steps per business process. That became the automation, and then we would distribute them based on what the client told us. I've put 10 in here. Maybe some of them are really short. Maybe they're only 3 screens or something like that. This can apply to web applications, legacy applications, Citrix, desktop applications, whatever you want. This could be just calling an API. Whatever you want that automated business process to be is fine. But once you've actually created it, you're probably going to run it once or twice within your IDE or within your automation product. So let's say you were using LoadRunner or NeoLoad or whatever. You're going to have the capability to, or JMeter, run that one time, and you have probably put in parameter files for parameterization. You're correlating dynamic session state type values. You're probably setting some behaviors that tell it you want think times in between steps. You want to pace the user out. That's what we talked about last time, was randomizing that pacing. When one iteration ends and the next one begins, how much time stays in there. And you also want to look at how long it just takes to execute that business process, and with a standard baseline of think time in there. Hey, I've got 10 steps, and between each steps are 5 seconds. I already know I've got 50 seconds of think time. Heavy duty execution time may only be 10 seconds or 12 seconds. So you add all that up and you've got about, maybe a 60-second window of time where this thing is running. Well, you would do that for every single one of these business processes and put them in however many they are. I would not recommend that you have, unless you've got the scope and the time, to try to do 40, 50 business processes, unless you're just doing like single API calls. But what you're really trying to do is you're trying to get the most bang for the buck on this particular load test. And we're really referring to more integrated tests. This is not necessarily the shifting left where I'm just testing out one feature. I'm banging away at that one API call with 50 virtual users and just hammering it for 15 minutes or something that a developer do. This is like your integrated system team in SAFe. This is your traditional performance load tester running these type of scenarios. So once we've got the business process listed there, I know possibly I've got a limitation by license. If I'm using something where I'm not limited by license, I may be limited by the infrastructure in my load test lab. And in this case, I know that I'm limited to 1,000 virtual users. That's what I'm wanting to ramp up to for my full 100% load test. If I can reach that and I can hold that test and reach the volumes that I look for, it's a pass and everybody's happy as long as the end user experience, it meets my requirement. So I have to break those up, but how many users are using, are actually doing user story number 1? How many are doing user story number 2? That takes a lot of questioning, looking at possibly logs, understanding seasonal behaviors, peak times. This is where it's the art of creating a load test scenario. There are no hard and fast rules, and every engagement is going to be different for you. So you've got to talk to the right people, get the right information, look at the right sources of information, and that's part of learning the craft of performance test or load testing. Once you have the numbers distributed, as you start putting them in there, this little pie chart will actually show you how you have distributed these users. So let's just say they gave you a number. The business said, we just want to make sure that the business process number 10, whatever that's called, I call it user story number 10, that 20% of our virtual users are running that thing. Well, if your number changes on the peak load of 1,000 to 1,523 and they suddenly say that's the peak number for us, you can still work on the distribution and make sure that this pie chart kind of validates that for you. The next column, transactions per iteration, means, okay, how many think time transactions do I have? Transaction timings do I have in that particular business process? User story 1 has 4 timings. Number 2 has 7 timings, etc. Then we want to know, based on our think time, we're going to start with like a baseline. If I have 50 seconds of hard-coded think time in that script, doesn't mean I'm not going to randomize it later, probably will, but I've only got 4 timings, but the whole think time of the script, that it's not executing its own code, is 50 seconds. And then I've got execute time with no think time. I've got, so one is with think time, one is without. I've got 21 pure execution seconds of think time. But then if I run it with think time, which is probably in here, this is probably 4 timings, and around those timings, before and after the time, there's probably up to a 10-second think time in there is what I'm guessing. So I had, 40 seconds or around, or 30 seconds, something like that, of total think time in there, and then I had 21 seconds of execution time out of that. You add those two together, and you'll see what I mean by how much time is being executed, the script is executing, and how much time is it's spaced out because there's think time in there. And then how many times does this thing need to iterate in a test period? I need 900 user stories 1s to run, and 900 iterations divided by 30 users. That's not that each virtual user is running 900 times. It's iterations per test period per that group. All right, now the next columns here, when I began, so I started this spreadsheet when I was using LoadRunner. I then started using NeoLoad for a similar, type of project, and I found that there were other columns that I could actually add in here and get more information. One was the request count. The number of requests and number of pages are displayed in NeoLoad when you run it through. When it tells you how many times that page was run and how many requests per page was executed on that. So I started plugging those numbers in. Doesn't mean that you have to, but if you get a page count and a request count, then when you move over to that second tab of that spreadsheet, you'll start seeing additional numbers, and it really helps understand, if I'm running this test at 100%, this is how many pages per minute, per second, per hour I'm running. Does that, when I talk to my technical people, ask the question, does that match what you expect to see in production? Does this match a realistic load test? So all this is trying to get me to that realistic volume amount as much as possible. So once you've filled out all these little aqua blue colors, then that's when the yellow stuff kicks in. That's when it starts its formula on, okay, how much execution time is actually happening per iteration, total execution time. How much, so it's 50 seconds of think time, remember, and 21 seconds of execution time. So it's adding those two together. That's simple. So we've got 71 seconds where it's in the process of trying to complete. You've got 30 iterations per virtual user. So to get 900 iterations from 30 virtual users in 1 hour, we need to run it 30 times. Okay, now that tells us what we need. So over the test period, see, we still have a ramp up to deal with. And in this spreadsheet, we have also included a 20-minute ramp up time. See it up here, I've already plugged that in. And it already knows 60-second window of execution time is 3,600 seconds. A 20-minute ramp up in front of that is another 1,200 seconds. So when it calculates these numbers, it's telling me, okay, well, I need 30 iterations during the 60-minute test window. But as I'm ramping up, I got to run another 10. So for the whole test, if you were to consider it an hour and 20 minutes, I need to run 40 iterations during that time. Now, notice at the bottom there, it says at least one. If this formula doesn't add at least one iteration per virtual user, you either got too many virtual users in the group or you're running them too slow, right? You need to run them so that you have at least one or two, I would prefer 2 iterations per virtual user, so your distribution might be off. So this is to help gauge you if your distribution is right. And then it just goes ahead and it adds up all these other things. Like if you do that and you get to 900 iterations, it knows how many timings you've got in there. So you're going to have 3,600 timings for user story 1. You're going to have 15,300 pages that are executed. You're going to have 23,400 total requests during that period of time. And then it takes that by business process that you've recorded, and at the bottom it adds them all up, and so it tells you by number of transactions, pages, and requests what you would achieve if it matches this particular thing. And then we get to what we talked about last time, which was the pacing. So it goes ahead and assigns a baseline pacing time of, for user story 1, 49 seconds, which means if we only stuck with the baseline timing, we would go into the setting and say, put a fixed number of pacing time so that when this ends, wait 49 seconds every time and then kick off another script for every user in that group. So 30 users are going to all wait for it. We don't want that, right? If they all wait 49 seconds, then they're all just sitting there at the gate with nothing to do. We're trying to spread out that load, which is why we talked about random interval pacing last time. So it goes ahead and it gives you the fast and the slow numbers. This is basically taking that baseline number, multiplying it times 0.7 0.7 and 1.3 so that you get that deviation. And if in that video, I'm thinking about it now, if in the last episode I said multiply it times 0.3, and then I was wrong. So it's 1.3 for a 30% deviation that's higher, and 0.7 would be a 30% deviation that's slower. So instead of 49 seconds as a pacing time, we're going to say wait a random amount of time between 34 and 64 seconds. Each time you end, well, the first time it ends, it might wait 38 seconds. The second time it might wait 52 seconds. The third time it runs, it might wait between iterations. You will still get the total number of times of iterations per user. 30 iterations, which is our column K, 30 iterations is what we're looking for, right? So if you use that random interval pacing, you'll still have that number. And it also does automatic user distribution that shows you how you are distributing your users in this spreadsheet, which is how we get the pie graph. That's how it's creating the pie graph. Now, because, last thing here, and you'll probably end up having to watch this video like 3 or 4 times to catch this, because I know I'm talking fast. You're going to want to go through the spreadsheet with me. You're going to want to download a copy of the spreadsheet, click inside of the yellow cells and see how it's creating the formula. Just break it down to one business process. Delete all the other lines that have user stories in it and just look across there and see the formulas that it's coming up with, and it'll be very easy to follow. If you're a great developer and you want to turn this into an app that somebody can just fill out a form and it does all that and spits it all out for you, that'd be even great as well. But as I began using this and I put in those additional columns from the NeoLoad analysis output, I was able to go to this second page and expand upon it. But before I do that, let me show you one other thing. At the bottom here, we have like total number of users for all groups. We're going to if you add all those up, you get 1,000 virtual users running. Then you get total number of iterations here, right? So that is if you take all of the scripts, all of the users, or all the business processes with all of the users, you're going to end up with approximately 26,550 total iterations that run. And then here are your 3 columns that kind of matter to me is, okay, how many total transactions am I going to have in my testing window? So it looks like 372,100. Then I've got about, a little over 1 million page requests per test duration, and 1.6 million total requests. All right. If I go to the second stats sheet here, you will see 20%, 100%, and 120%. What does that mean? Okay. That means that I'm going to run a test at this full load that you just saw all these numbers for. That would be a 100% baseline of getting up to 1,000 virtual users. But before I run that test, I always run what I call a top time transaction test. Now, what's a top time transaction test? That is taking whatever those numbers are and just saying, you know what, I'm not going to ramp up to 100% first. I'm going to ramp up to 20%. So in this case, I'm going to run a first test, and I'm only going to go up to 200. Now, because my iterations, settings, my random my pacing, my think times, all of my behavioral settings are the same, I'm keeping the distribution the same. I'm taking the right amount of virtual users out of each group to keep my distribution the same. I'm just taking the numbers down to 20% of that, and I'm running that test. I'm still ramping up, still 20 minutes, but I'm only going to reach 200 instead of 1,000. Why do I do that? Because notoriously, I have gotten in trouble by just trying to ramp up to 1,000, because sometimes companies don't realize that they have bitten off more than they can chew. And sometimes they have grossly set out to do more than what their system is capable of handling. So by going to the 20% level and ramping up to 20% of what I think full load would be, I'm able to see patterns start occurring in performance degradation without hopefully destroying a database or taking something down or causing an outage. It should be minimal impact to the system, but I will generally, especially if they've overdone it on the numbers, thinking that they could do that many, it kind of resets it for me, saying, you know what, you guys are never going to make it to 1,000 users. We can barely make it to 200. I'm so glad I ran that test at a lower level. But let's say that I do reach that. You will come out with numbers from your load test analysis. Your load test results should tell you, hey, this is how many transactions I ran. And you can, I already know from this spreadsheet, I've already plugged in for 20%, then a full load test of 100%. Let's go back and look at that. I will have run a 20% test. I know I'm going to run a 100% test, which is my 1,000 users. And if I know they're going to be growing and they want to do a scalability test, let's say they expect to get 20% more users on the system in the next year, I might run a 120% test, or I might run 150%, whatever that number is above it. But these numbers that you're seeing here are not numbers that are coming out of my test analysis in this upper part here, right? Where it says 30% low, no deviation, where you see the 52,000, the 75,000, etc. These are numbers that are calculated from this first page. So whatever numbers come up here in these columns, that's what it's using for that second page. And hopefully I haven't lost you. It's just basically saying that if you run a test with that scenario profile that you've set up on that first page, if you had no deviation whatsoever in your script, if you took all the randomization out in this particular case, and you ran 100% test, line 5, which I'm highlighting, you should end up with about 375,000 transactions. Okay. All right, let's move to the 20%, just because I know that's what we're gonna be comparing here. Line number 4 is a 20% test, and if I took all the deviation out, I should end up with somewhere around 75,000 transactions during that test. Now, because I know I'm adding a 30% deviation, and 30% is just one number, I could have made that a 40% or a 70% deviation and just changed the formula for that. I'm running it at a 30% deviation. It's already calculated the low numbers and the high numbers. So if I were to hit the lowest number, I would hit around 52,000 transactions. If I hit the high side of the 30% deviation, I'm going to reach about 97,000. When I ran the actual test, that's what you see down here in yellow on line 9. I hit 79,000 transactions. So what does that mean? When I ran that particular test, all things considered, all randomization in there, I hit it right about on target of what it would be for right on the center. But as you run more tests, you're going to see it go a little bit to the left and then go a little bit to the right. And this is why I like to run more than one test. I like, when I get up to the 100% load, I like to run 2 or 3, maybe more tests over a period of a day or two to see. The first test, oh, it was very aggressive. I was expecting somewhere between 375 to 400 thousand transactions. Dude, you hit 500,000. All right, you totally blew past your 30% deviation on the high side. You need to go back and look at these numbers, make sure they're right, change some of these numbers, and bring it back in line. So it's not that you're trying to keep that volume right, but you're going to hit it on either side of no deviation. You just don't know how much until you actually run the test. And the test results analysis should show you this is the total number of transactions that you had during this test window. Then you compare it to the spreadsheet and find out, does it match at all? All right, I've done that for, as you can see in the spreadsheet, transactions up here at the top, line number 2. I've done it for calculations for transactions. And what you're seeing here in line 9 is an actual test that I run. So we see the transactions hit at 79,000. The pages, okay? Even though my transactions 75 and 79 really aren't that different, but from a pages perspective on that same test, no deviation would have produced 200,000, a little over 200,000, right? I hit 187, which means I was hitting on the lower side of right down the middle, right? So I was probably, I'm closer to 20% or more deviation there. And then if we go over to requests, the number of requests was 275, which is sort of about the same. It's above the lowest number of 30%, but it's kind of on that side. So if I just went by the number of transactions, 79,000 transactions, wow, I mean, I'm hitting that right almost dead center. But then when you look at the pages and request, it's over here. It's the lower side. So the next test I might run, what if it's on the upper side? I might still see, few more transaction numbers, but I might see a lot more requests and a lot more pages. And that's why I like to track the volumes of all 3, transactions, requests, and pages. I hope that hasn't confused you too much, because anybody who is familiar enough with Excel, you can go in there and look at these formulas. And some of you may be yawning right now because these aren't technical enough and you don't see any sense in these. But this has really helped me put together load testing scenarios and make them as accurate as we might see in production. And I've had, several companies look and try to challenge these numbers. And once they actually look and they go, well, we look at our web server logs, we look at how many writes and reads we did to the database, and it matches about the traffic we're doing in production. And based upon what we told you, you built that scenario the right way, and it kind of keeps me out of trouble. So once I can start plugging in those values on page 2, and when it's doing all the transaction, when it's doing all of the formulas for me to figure all this out, just saves me a lot of time in creating tests. So once I get the 100% test formulas, it's easy to create a 20% value of that, ramping it down, and then taking 100%, just going up 120% test or 150% test or a 200% test, whatever you want to run. Then let's say that you want to run a stress test. Well, then all bets are off. You remove all that think time, you remove all that random pacing, and you just try to kill it. Is that information necessarily as beneficial to the business? Maybe not, unless they're able to make some decision about what to do about it. If I can kill the web server in 10 minutes, ramping up to 20 users, but there's a huge multiplying factor there of how I'm hitting it. Unless they're just wanting to say, okay, well, we know the web server is going to be the first thing that falls over when we get a DDoS attack or something like that, they should probably get a load balancer out and get another web server, put one more web server behind it, and see, is the problem alleviated? No, put another web server behind it. Is the problem alleviated? Oh, well, now it moved down into the next tier down. Okay, well, now we've made some progress there from a stress test, just for finding out which tier is going to be the first bottleneck of the system. And we're trying to move that to further and further along to the back end. So I hope this was helpful to you. I'd love to hear your feedback about this. Tell me if it was confusing. Again, we've got the download links for all of this stuff, and you can watch this again as you go through it with me. Would be helpful if you told me what you thought. Find out and get back with me. You can reach me at scottmoore.consulting, through LinkedIn, or through Twitter. You can also email me at help@scottmoore.consulting. And it would also be great if you signed up for my YouTube channel to be notified when there's new content coming out every Tuesday and Thursday at 8 a.m. And the more subscribers that I have, the more it tells me you're on the right track. Keep making shows and keep going. 50 shows since January of 2022. We've got 50 more to go until we end the year, so we've still got a lot more stuff to talk about. But that content hasn't been created yet, and it's up to you to help me figure out what's more beneficial to you. Are you a performance engineer? Do you do load testing? Are you an SRE? Do you want to talk about observability? Do you want to talk about the golden signals? Do you want me to interview some influential person in this realm that's not me? And happy to do it. Just send me your feedback. It'd be great to hear from everybody. I do want to say, 50 shows. It's been great so far. And I'm having, if you can't tell, I'm really having a lot of fun doing this. So I hope to keep doing it for you. For this episode of the SMC Journal Podcast, this is Scott Moore saying thank you for watching, and we'll see you next time. Bye-bye.